let's get on to the graphs. So sine and cosine act in very similar ways, all right? So basically, they can go to infinity in both directions. Okay, there's subtle differences between them, but what you're going to notice is we're interested, there's values in between all of these degrees, okay? But we're only going to put points on these degrees, and you'll see why here in just a second. So sine starts at 0, 0. Okay, can you see that color? It pops up to 1 at 90 degrees. It goes back down to 0 at 180, down to negative 1 at 270, and up to 0 at 360. So when we do this, we want... Alright, so, when we're drawing this, we're going to be curving, and it curves down. Oops, I'm having a hard time with this tablet here, because I am now holding Audrey, so I can't have this on in front of me. Okay, so it pops down to 0, and I'm curving like this, and it pops back up to 360. This is one complete cycle for sine, and I'm going to do the next one in purple. So it's the same idea. We start at 0, pop up to 1, pop down to 0, down to negative 1, and at 720 degrees, we're back up to positive 1. So this continues, oops, like this. And when you do this, you need to make them curved, because they're not V's. Okay, and yours should be prettier than mine, but mine is really hard to do on a tablet, so no excuse, but still, make your graphs a little neater than mine. Okay, so there we go. So that's how this looks, and it continues the same way. Okay, for the negative values, it goes... Okay, I'm having a horrible time here. It still continues, so we go down to negative 1, up to 0, positive 1, and back down to 0, so it might be easier for me to do it this way because I'm right. And it goes like this. So it kind of just looks like a big snake, right? That's all curved, okay? So we would consider, and I'm going to use this vocab and we're going to go into it more, from 0 degrees to 360 degrees, that is considered a period for sine, because that's when it completes one complete, and in math we would call these sine wave, okay? A second sine wave happens in full in the next 360 degrees, all right? Okay, so make sure you have this sketched in your notes on graph paper, okay? If you need to come back and look at it, that's fine. All right, so let's move to cosine. So sine and cosine are very similar, okay? With subtle differences. So remember how sine started at 0? Well, cosine starts at 1. So it starts at 1, it pops down to 0, pops down to negative 1 at 180 degrees. At 270, it pops back up to 0. And at 360, it completes its full cycle, meaning that it also has a period of 360 degrees. At 360, it starts at 1 and ends at 1. So what you're going to notice is they start and end on the same value. So this one is still curved like this. Okay. Hopefully yours looks a little better than mine. Okay. And then it starts again. So down to 1 at 540, down to negative 1, up to 0, and then finally all the way back up to positive 1. So I kind of like to think that, when you're trying to keep which one of these is straight while you're still learning them, I always think cosine kind of looks like a valley because it kind of goes down and comes back up. Okay, so again, this would continue in the opposite direction. Okay, just like it did here. So I'm making my points. You'll notice there's only 3 possible values, 1, 0, or negative 1 that we graph, and then all the values in between, of course, between negative 1 and 1. And we'll talk about why that happens in a second. Okay, so here's my cosine wave. Alright, so again, its period, it completes a full wave in 360 degrees. So here's one full wave, and another 360 degrees. It completes a second full wave, and so on to infinity. It would keep making cosine waves. Alright, so before we start looking at the graph of tangent, we need to talk about the relationship between sine, cosine, and tangent. So if you remember, tangent of some value, of some angle, is equal to the opposite over adjacent, okay? Sine of some value is equal to the opposite over the hypotenuse, and cosine of some angle is equal to the adjacent over the hypotenuse. Alright, So basically, what you're going to notice is tangent is the only one without hypotenuse, okay, in it. So I'm going to show you something that's really cool, well, that I think is really cool. So here we go. I'm going to solve one of these for h, and actually I'm going to solve sine for h. So I'm going to get h on its own side, okay? So I'm going to say h times sine of x, because I'm multiplying both sides by h, equals opposite, and I'm going to divide by the sine of x, okay? So now hypotenuse equals opposite over the sine of x, okay? Not too bad. Kind of what we did in the problem before. Well, cosine has an h in it because it also is being divided by the hypotenuse. So I'm going to say the cosine of x equals a, and everywhere I see h, I'm going to put in what h equals, okay? Which is the opposite divided by the sine of x, okay? Good so far? Okay, so here we go. I want to have, well, this is just really messy, so I'm going to multiply by the reciprocal sine of x over opposite, and then times sine of x over opposite to kind of get this cleaned up a little bit. Okay, so cosine of x is equal to a times the sine of x, all divided by o. Alright, let's get that o out of the denominator. You'll see where I'm going here. You're probably wondering if I'm leading you on some crazy goose chase, but I'm really not. Okay, so o times the cosine of x is equal to a times the sine of x. Okay, I'm going to divide both sides by cosine of x. I'm going to divide both sides by the cosine of x. Okay, I just said that. Doing it again anyway. Okay, so o opposite equals adjacent times the sine of x divided by the cosine of x. Alright, and finally I'm going to divide both sides by a, or multiply both sides by 1 over a. So I end up with opposite divided by adjacent equals the sine of x divided by the cosine of x. You might be wondering why I made you do all of this algebraic manipulation. Well, here's why. The tangent of x is equal to the opposite over adjacent. Well, I have opposite over adjacent here, and that equals sine divided by cosine, okay, of x for both of those. So technically, mathematically legal, I can go ahead and substitute sine of x divided by cosine of x. Okay, this is a very, very important trigonometric identity, okay? This is how we calculate tangent. We take whatever sine value is, sine of some angle, and we divide it by the cosine of some angle. Alright? That's what tangent technically is. Instead of using opposite over adjacent, this is what it means mathematically. So, that should lead you to think, well, if we go back to our graph of cosine, cosine equaled 0 at 90 degrees, at 270 degrees, at 450, and so on. Every 180 degrees, right? Starting 90 plus 180 is 270, right? Every 180 degrees, starting with 90 degrees, there's a value of 0 for cosine. Well, if tangent of x is equal to the sine of x divided by the cosine of x, that means that anytime cosine equals 0, I'm going to have a 0 in my denominator, and that, well, you can't do. Well, do you remember asymptotes from our earlier studies? Anytime there's a 0 in the denominator, we have an asymptote, right? A line that our graph will never touch. Well, in this case, every value that yields a 0 for cosine, okay, cosine of 90 is 0. Cosine of 270 is 0, right? Cosine of 450 is 0. Our graph of tangent can never touch, okay? So tangent's kind of a interesting looking graph because it has all of these asymptotes, okay, in it. And then we're basically, for the other values, it's a ratio of sine divided by cosine. So here's how our tangent graph looks, okay? When sine is 0, tangent also has a value of 0. So I'm going to plot those here really quick. So sine is 0 at 0. Sine is 0 at 180. Sine is 0 at 360. Noticing a pattern here? Okay, you should be. So tangent touches the x-axis when sine equals 0, because when sine is 0, the whole function equals 0. Okay, so our graph is going to, let's see if I can draw this. Our whole graph is going to look something like this. Kind of looks like a little snaky thing, and it repeats itself. Okay, and it goes to infinity in both directions, and it approaches that asymptote. Hopefully your lines are looking like it's coming down and trying to touch that a little better than mine. Okay, this is how the graph of tangent looks. It's kind of weird, yeah? Okay, all right. The reason why you now know is because when sine equals 0, our tangent touches the x-axis, and when cosine is 0, cosine of x is 0, it creates an asymptote that our graph can't touch. So what you should notice is every 180 degrees, our graph repeats. Every 180 degrees, we have an asymptote. Every 180 degrees, we have a sine graph between the asymptotes. That means the period of tangent is not 360 like sine and cosine. It means it's 360 degrees. All right, so technical definition of a period of a function, it's the smallest interval before the function repeats itself. So remember how I was talking about saying, look, it's 360 degrees before the sine wave starts again. Well, that's because that's the definition of a function. So just as a reminder, sine and cosine both have periods of 360 degrees. That's when they start to repeat. Tangent, on the other hand, repeats every 180 degrees. Here are the periodic properties. For every 360 degrees, sine has the same value that sine of whatever had. So if I jump back to the graph of sine, oops, I jumped way back too far. Sine, what you're going to notice is at 90 degrees, sine has a value of, or at 90 degrees, sine has a value of 1. 360 degrees later, at 450, sine has a value of 1. If I go in the negative direction, 360 degrees in the negative direction, sine has the same value. It's the same for every point on this function. Every 360 degrees, the values repeat. So I can take the sine of some degree and add 360 to it, and I will end up with the same degree, or the same value for sine. I can take sine of some angle and take 360 degrees away from it, and I'm going to end up with the same sine of some angle. Okay? Cosine works the exact same way. All right? Tangent is similar, right? Every 180 degrees our values repeat. So if I have the tangent of some angle and add 180 degrees, right, I get the same value that I had for tangent. All right? Not too bad, and we will be practicing this in class. Okay. So you might be wondering, what is next? This seems like a lot of information. Well, this is the basis of trig, so it seems maybe a little daunting. But we're going to learn why trigonometric functions sometimes are referred to as circular. So why are they sometimes referred to circular functions? And I'm going to give you a hint on on our graphs for sine and cosine. What was the maximum value for sine? 1. Okay. What was the minimum value for sine? -1. The maximum value for cosine was 1. And the minimum value for cosine is -1. Make sure you write that in your notes because it is going to lead us into what we're doing next, which is looking at these as circular functions.